So the concept of iBelieve is really interesting. First of all, would anybody tell me why they're here? Anybody? This is a really interesting phenomenon. We're running an iBelieve event, and people turn up. And it's really strange. The very first one that we did in the US, the reporting was actually calling me Preacher Perry, because it's a bit of a religious event. We're all religious about IBM I, right? Yes, yes. Who loves Windows? Security! Who likes Linux? Who likes... I mean, we are very passionate about our platform. Okay? And I must say that we actually do have to pay attention to what we call it. It isn't an AS400, and we're not celebrating 25 years of an AS400. We're celebrating IBM I. And that's a new animal. That's a very different thing. And so we're going to talk about that today. And you're going to see some of the past with Dr. Frank. You're going to see some of the present and what people are doing with it to make it be a very different platform than what it's been. And for a lot of us, it's been our history. How many people have actually were born within that 25 years? Who is younger than 25 years? Oh. Are you? How old are you? 48! Who's younger than 25? Younger. Who's less than 25? Nobody in the room. So far, in all the iBelieves we've had 3 people who are younger than 25. So what does that mean to us? What it means is that we're an old demographic, correct? Okay? Most of us are bald, and some of the men. That'll take a while to sink in, yes. The interesting part is as we've become an older demographic, we've been threatened. And today is not about the threats. It's not about IBM hasn't done this for us. We get that a lot. It's about celebrating what IBM I can do. And so that's what today's about. Today's about celebrating. And so we're going to learn some things and reconnect. And my hope for you when you leave today is that your passion for this platform is reignited. Right? Who came for that reason? See, it's really interesting when I ask that, people go like this. It's like, oh, hang on, I'll wait for somebody else to put their hand up. So it's fascinating. I want you to relax. We've got some really wonderful speakers, right? And this is my first time in Vienna, and I get to see the airport and the music hall, music house, and that's it. Because I'm leaving again. So we've got to hurry because we're going to play. No, we actually be here for the start of the celebration and the birthday cake. But you do have Dr. Frank here to cut the cake, and also to give us some great stories about IBM I and celebrate IBM I. So please welcome the father of the AS400, Dr. Frank Soltis.
Thank you. Good afternoon. It's great to be back. I have been here a number of times, Trevor, and I have seen more than just the airport.
Is it worth it?
Yeah, I think so. You might want to plan to come back.
Okay.
There's a few things. Is Trevor 38? Now, for a lot of people that have been around for a while, they realize that System 38 was an AS400. We announced the System 38. 10 years later, we changed the name. We put some new hardware with it, different funny-looking box. And we called it an AS400. Today it's IBM I. So in fact, this particular platform has been around for 35 years. Now, what I get questioned on many, many times, especially when I'm talking to press people, is that many of them will say, what was it about it that lasted 35 years? And of course, what they're saying is that if we go back 25 years ago, when we announced the AS400, and we look at all of the competitors around the world, and by the way, there's different competitors in different parts of the world. And back in those days, we always talked about mid-range systems or whatever that was called. And if you looked at all the competitors from all of the vendors everywhere in the world, one thing is absolutely certain. They're all gone. Every single one of them has gone away. Now, in some cases, the companies that built them have gone, okay? I mean, it's not just the platforms, it's some of the companies that built them. And oh, by the way, if you go back 35 years, you fundamentally can't find anybody else that still is in existence. Because computer systems have a habit of going away after so many years. And some people ask me, why? What's the difference? Well, one of the things that's an absolute certainty in this world is that technology changes. And if you design a system that is designed for today's technology, it will be guaranteed to die because you won't be able to keep up. And that's exactly what happened to each and every one of those. People would build the system for that current technology when they introduced it. Now maybe that's not so bad. Certainly in the early days, there was a belief within IBM and in the industry that a computer system had a life of 5 years. 5 years, only 5 years. And at the end of that 5-year period, you had to introduce some new computer system, right? Well, we did something a little bit different. We decided, with the System 38, to build it for future technology. Not for the current technology, but for the technology of the future. And you say, well, how did you do that, right? What the technology in 2013 would be. Well, we didn't. So we made it such that you could make changes to the technology, whatever it was, and continue to run that particular platform, right? Now, we also did something that was rather unusual. You notice the symbol often that you see, I, it says I for business, right? What other computer system in the world advertises it's for business? None. Why not? Because none of them were ever built for business. When I first joined IBM 150 years ago, I started to work for an organization that was going to build computer systems for mid-sized, today we say small and mid-sized businesses, right? And they were going to build business computers. And the first question as I walked in the door, literally, was what's a business computer, right? I was coming out of the university, and in the university, a computer is a computer is a computer, right? I mean, they're all the same, right? You go to almost any place and you study computers, you kind of know what they are, and they're all the same. And when you say a computer for business, what's that all about, right? And so they spent an awful lot of time explaining to me that businesses have some different requirements. Businesses, for example, especially small and mid-sized businesses, cannot afford to hire a huge staff, because if that's what it takes to run a computer system, which by the way in the early days it did, right? I mean there was a highly trained, very expensive, big staff to run some of the early computers. And you just can't afford that. So fundamentally the system had to run itself. It's one of the concepts behind it, right? What's the most important thing to a business? Is it one of these boxes? No. It's not the hardware. It's the applications is what runs the business. You got to protect those applications. And the minute you get to a point where you can no longer run applications for a particular business, you die. And by the way, that's what happened to almost every other platform out there. Is they got to a point where they had to make fundamental changes to the system. People had to throw away their applications, rewrite new ones, rebuy new ones. They refused to do it. The platforms died. In many cases, the companies died. They went right with it. And so they said, there's a difference in there in business, okay? Now, granted, today, you can run your business on Windows. I don't really want to, but you could run your business on Windows. You can run your business on Unix, right? I mean, people do. You can run your business on a mainframe, right? No problem, right? And yet I just said none of them are designed for business, right? They're not. They never were. Go back in the history of IBM. IBM got into the computer business back in the 1950s. And at that time, they decided that they were going to build two completely separate lines of computer systems. They built one line of computer systems that were for scientific processing. Okay, if you wanted to do weather forecasting, whatever, here's what you buy, right? They built another one which they called commercial systems. The two lines of systems were very different, okay? And so when you went to IBM to get a new computer system, you had to choose. Do you want the one that's for commercial, for business, okay? Or do you want the one that's designed for scientific computing, right? Well, as time went on, these were very successful systems, but they had one flaw. The flaw was that they had multiple models in the, let's say, the commercial line. And let's say you were a particular business, whatever size it was, and you were using one of those, and by the way, your business grew, right? and you needed more power. You needed a bigger computer system. Well, IBM would happily get you a bigger computer system, but it had a slight problem with it. It was incapable of running the software from the previous system. In other words, when you grew to a new computer system, you had to do a minor thing of rewrite all your applications. Because software had no value at the time, right? I mean, it's just a program. And obviously you have a big staff of programmers, they just rewrite the programs, right? Well, a funny thing happened in the early 60s. Customers said, we're not going to buy from you anymore. And in fact, they began to buy from other companies who would ensure that you could grow in the product line and still support the same applications, okay? Now, by the way, in the scientific community, that never happened as far as growth. In the scientific community, up until about 5 years ago, whenever you put in a new supercomputer, I mean, we build in Rochester, Minnesota, which is where I live, we build all of the IBM supercomputers, the biggest things in the world, okay? And one of the things up until about 5 years ago is if some national laboratory or something bought one of those new supercomputers, they literally threw away all the software, all their applications from their old supercomputer and rewrote it. And it wasn't until about 5 years ago that some of the government organizations buying these computers said, you know, we can't really afford to do this. And they gave IBM a multi-million dollar grant to come up with a way of protecting the investment they already made. In other words, they wanted to run the same software, right? So it really just happened about 5 years ago. But in the business world, it happened in the early 60s. So IBM said, oh my gosh, we got to fix this, otherwise we're going to go out of the computer business. And they undertook an effort to build a completely new product line, which became the 360, where all of the models used the same architecture. And by using the same architecture, they could run the same applications, the same software, right? They also said, well, this keeping together the scientific and the commercial as separate lines, we're not going to do that, we're going to merge them all together. So they built a more general purpose computer system, and you could go from one step to another. So that was goodness, right? What kind of processing was the world doing in the early to mid 1960s?
Batch.
Batch. That's all they were doing was batch. And so the design of the 360 was optimized, and really was optimized to do batch processing, strictly batch. Now, interestingly enough, how do you measure batch computing? Generally, you look at how fast the processor is running. So you come up with some measure of how many instructions you can perform in a certain period of time. In the mainframe world, it's called MIPS. And you may notice that even today, when IBM ships a new mainframe, they talk about how many MIPS it has. In other words, they're saying, what's its capability to do batch? Okay? What kind of processing do we do today? Well, we do some batch, right? But most of it's transaction-based, right? And in fact, that started to change in the early 70s, by the way. You know, one of the things that you had in the 60s is nobody really had terminals attached to their systems, right? It was really batch. It was a pretty much standalone batch is the way they were being used. And then we started attaching terminals, right? And so suddenly you got multiple users. You have to be able to switch between those users. You have to be able to execute literally transactions. Now, in those days, we call it interactive and all their other names, but I mean, today we talk about a transaction-based. So when we talk about what's the future, we talk about things like cloud computing, we talk about analytics, and by the way, we've got, I think Simon's going to be here talking about some of that, so I'm not going to touch too much on that. But if you look at where the world is going as far as applications, IBM's view of a smarter planet and everything tied together, that's transaction processing, simple as that, right? Well, wait a minute, I said in the early 1970s, IBM came along with a mainframe, some new models of the mainframe, they called it the 370, it's basically the same architecture as the 360, and it had to run transactions, right? So what could they do? Well, they put a patch on it, a piece of software, right? CICS. Anybody remember CICS? Well, probably not, but I mean, it was a transaction processor, that's what it is, right? IMS, I'm talking about some really old stuff right now. But they put, if you will, patches on, software patches, right? Because they couldn't change the fundamental architecture to be that. So if you're using a mainframe, and by the way, mainframe, I love mainframes, there's nothing wrong with them, right? But they were designed as a batch system, okay? Okay, so you're running your applications, you're running your business on Unix, right? Unix was designed for transaction processing, right? No, it was designed as a single user workstation, also in the 1960s, right? Okay? One user. So what is one user going to do, right? Well, maybe I've got a wire, in fact I'm going to have, if it's a workstation of some kind, attached to something else, right? But I'm still doing one user, I'm still doing a batch type of job. I'm running one application on this thing. So once again, in the Unix world, oh my gosh, they got to put on transaction processors, right? And by the way, both of them over a period of time, people thought they might want one of these things called a database. I mean, who does business computing without a database these days, right? Who does anything without a database, right? So by the way, they patched them on, right? It's more software, okay, on both of those. Well, the good news is that Windows is newer, and so obviously it was designed for transaction processing, right? Exactly, yeah. Funny thing happened in the early 90s. In the early 90s, late 80s, Windows was, sort of a veneer on DOS, right? And Microsoft decided that what they wanted to do is have a real operating system. I mean, truly a real operating system. And one of the things that happened at the time is Digital had decided that their VAX system, I've always been a big fan of VAX. Around universities, VAX, running VMS. I mean, they were fabulous systems. They really were back in the early days. Had all kinds of fun with them. And they decided they didn't want that anymore. Digital decided, it's not good anymore. Digital decided that we're going to go to Unix, we're going to be running it on the Alpha processor, right? Their Alpha RISC processor, which by the way is a fabulous RISC processor. If you look at today's power technology, you look at the latest Intel kinds of things, what you find underneath there is technology that's from Alpha. I mean, it really is. And in fact, when Digital sort of folded up shop a few years later, after they made that decision, there was a mad rush to get the designers of Alpha in both of those companies. So, we recognized a good design, we really did. Okay. Well, anyway, they decided that they didn't need VAX, they didn't need VMS anymore. And so suddenly there was a group of people that were responsible for VMS development just outside of Boston, Massachusetts in the US, didn't have a job because their job was to work on the next generation of VMS, right? And so an interesting thing happened. Microsoft hired them all. They hired the whole team, right? And they went to Redmond, Washington to work for Microsoft. And in 1995, Microsoft introduced a new full operating system, not a veneer on DOS, but a full one called NT, Windows NT, right? And Windows NT, the early version, had a strange thing happen, right? Whenever it would blow up, it put up VMS error codes. Slight problem there, right? Digital, of course, saw that and said, wait a minute, you just stole our operating system, okay? Windows NT was VMS, okay? There was some hasty negotiations between Digital and Microsoft bought the rights to own VMS. And so, if you look at today's Microsoft Windows, it's a derivative of that. It was designed back in the 1960s as a single user workstation on VAX. That's exactly what it was. It was never designed for anything beyond that, essentially doing batch programming. They had no concept in those days of transaction or interactive programming, right, when it was designed. So even at that. And of course, we identify one of the tricks, of course, is that if you take the letters VMS and add one letter to it, you get WNT. And that's, sort of a little programmer trick of, that's why it was named Windows NT. So everything that exists today is designed for batch. The System 38, we designed it, we had 10 years later, because we designed it in the 1970s, announced it in 1978, was the very first system designed for transaction processing. The architecture was designed for interactive transaction. Do you use batch? No, of course not. You use a transaction-based measurement, right? And some people remember, certainly in the early days, when you would get an early System 38 or even some of the early AS400s, right? They'd run like crazy on transaction-based workload, and then all of a sudden you put a batch job on it, and it went, I mean, it didn't have the power really to do it because it was designed for transaction-based processing. Right? So one of the things is the design of it was very much of a futuristic design, which is part of the reason it survived. Continue to do that. I told a story in some of the one of the early sessions of a little problem that we had in IBM. We designed this, crazy thing called the System 38, and not only was it designed for transaction processing, but it was the world's first totally virtual machine. Now, think about it. Today, everybody but everybody talks about virtual machines, right? We've all got virtual machines. That's just the, standard of the world, right? But, 35 years ago, nobody knew anything about virtualization or, virtual machines. The best there was is the mainframe had some virtual memory, but that was just for the memory, right? It wasn't a total machine. Now, in those days, we didn't call it a virtual machine because nobody used that terminology. We talked about it as technology-independent machine interface, right? You say, what's that mean? Well, that means that all the software, you can rip out all the hardware, put in different hardware, and the software still works. That's what a virtual machine is, right? I'm running a virtual machine on some other platform so that I can continue to run the software that's developed for that virtual machine. That's what we were building, right? Well, this is a pretty radical design, especially for IBM, who had sort of made the decision that they're going to be building these batch systems and continuing to build those and so forth, on and on. And one of the things that happens in IBM is before you have any system announcement or any big announcement, IBM asks other divisions to take a look at this new product. Is this new product going to do what, the people who are announcing it say it's going to do in IBM? All that sort of thing. In other words, they sort of do a technical assessment of it, right? So in 1977, this is 1 year before we were ready to announce, IBM asked, is it going to look good for our research division, our, large systems division, several people throughout the corporation, technical people. Take a look at this thing that those folks in Rochester are building and give us your assessment of it, right? They did. They looked at it. They came to a conclusion. They said, it won't work. It won't work. They said, we've never designed a system in IBM like that. Nobody's ever designed a system like that. It won't work. And there's all kinds of reasons why it won't work. Stop the presses, right? You can't announce this. It'll be a total disaster. It won't work. Well, they're partially right, but we didn't mention that. We had, in Rochester, Minnesota, 1977, the biggest audit we have ever seen, technical audit. The corporation sent a lot of the absolute top technical people in the company to Rochester for a 3-week period. And one of the things that was so funny about it is we had just finished some of the buildings there. And in fact, these are more like warehouse buildings because we were going to put manufacturing and stuff like that in it. So there was this big, huge open building, right, that had walls and a ceiling, and that's about it on it, right, with a kind of a dusty cement floor and everything like that, this huge thing. They put in big tables for these people doing the audit, and a lot of metal chairs for those of us that, were a part of the Inquisition. I mean, it was an Inquisition. They were there to explain to us why this will never work. How could you people be? And I had the wonderful opportunity to speak to this group, right, and take them through it. And they needed, detailed information on what we were doing, why we were doing it, whatever. And so one time I was presenting some of the benchmarks that we were running, because you always run some benchmarks before we announce, right? And, just to test how it's doing and what kind of performance it's getting and so forth. I was running some benchmarks. And was showing them that we, on average, we're executing about 1,000 instructions, and then we'd switch to another user, execute about another 1,000, switch to another user, and so forth. Demonstrate, kind of how many transactions we could be processing and so forth, right? And was explaining this, and some of the people in research and also from the mainframe organization basically jumped up and said, that's your problem. You're not getting any work done. What do you mean we're not getting any work done? He says, you're not getting any work done. So, well, we're executing 1,000 instructions. We're getting some work done, right? He says, you don't understand. On the mainframe, to switch from one user to the next takes 1,000 instructions. The mainframe executed 1,000 instructions just to switch between users. So if we're doing 1,000 instructions, we're just switching from user to user to user, not doing anything. Well, why do they use 1,000 instructions? Well, if you take a look at any computer system, And by the way, every one of them out there does something similar to that. Maybe it's not 1,000 instructions, but whatever. Is that they have to start clearing out a lot of registers because these things are using virtual memory. And the virtual memory translation tables are built into the hardware, right? And they're using the same addresses. You know, my program and your program use the same addresses, but obviously it's pointing to different data, so we have to have different translation tables. So they got to unload all those, load the new ones back in. There's a lot of register cleanup they have to do. They execute 1,000 instructions, okay? Wow, okay? That's it. This thing is not going to work. And so I said, we don't execute 1,000 instructions to switch from one user to another. We execute one. One instruction. One. Blank look, you know. I mean, you know the look, right? It's kind of like, what did you just say? What's that instruction? Branch. It's a branch instruction. We just branch to it and start to execute. Why? Because we've got this huge storage, right? A single level store. And yours are different, right? Even though your program may say address number 100 and mine says 100, we've got internally different addresses. So I can simply branch to the data field or branch to the instructions of the next user and start executing. It takes us one instruction. It's designed for transaction processing, not batch, right? So they said, oh, now you've got some real problems. Looking back on it, by the way, this was, I can look back on it and it was fun. At the time, it wasn't a whole lot of fun. Standing up in front of the experts in the corporation, right, who are telling you that what you just did doesn't work. It's not a fun thing. Anyway, they said, here's your problem. Now, any user can branch any place they want. They can branch to somebody else's instructions, execute that. They can branch to somebody's data field, maybe accidentally, and start executing data, which of course doesn't make any sense. It's just this ugly thing. If you can branch, you can go anywhere, right? I said, well, no, of course you can't. Because everything's in objects. And then I get this, what's an object? When I was back in the university, I was trying to demonstrate a research project that I had so that I could actually get a degree and get out of there. And the research project was basically what it turned into single level store. And so the university had a mainframe, had an IBM mainframe computer. And so one of the thoughts I had is if IBM would let me go in and modify the hardware of that mainframe, I could actually demonstrate on the mainframe what it could take to use this single level store. Now, can you imagine IBM saying, okay, here's a graduate student, go ahead and modify our computer system? Yeah, right. So I had to come up with a simulation, okay? And in those days, the simulation language that was very popular was something called SimScript. And SimScript was really fascinating to me because if you had some part of the computer system you wanted to simulate, but you didn't care what the internals were. In other words, when you gave it certain inputs, it gave you back certain outputs. You didn't see what's in the object, nor did you care what's in the object, right? And it was a great way to build a simulation where you only had to have the detail on the pieces of the system that you wanted to show, and the rest of it you could actually put in objects that worked that way. By the way, about 2 years later, a version of SimScript was introduced, and it was called Smalltalk. Smalltalk being really the world's first object-oriented language. So when I went to IBM, I was gung-ho about this concept of objects, right? And so I explained to them that you have to have authority to the objects, right? If you're going to branch somewhere, as you will, you've got to make sure that the operation you're going to do on that object makes sense. In other words, you don't execute data, you execute instructions, and so forth, right? We protected it that way. Because as I pointed out to them, that in a business computer, one of the most important things is security, right? Got multiple users on that, security. My security isn't a lump on the top, a piece of software, that by the way, anybody can get under, right? And by the way, as you find all these back doors into these chunks of software, we get hacking, we get all this nonsense, right? We built it in, including hooks in the hardware to do this. There's never been a virus on a System 38, AS400, IBM I, whatever we call it over the years. Never. Never. Absolutely never on the native system. Now, by the way, in the IFS, we carry around Windows data, so we could be transmitting viruses in there, right? But they don't affect the system, right? They can't. We've never had one. Over the years, within IBM, we tried to claim that this thing was virus-proof, advertise it, let's, hype it. And of course, the IBM attorneys would never let us do that. IBM hires more attorneys than engineers, they do that sort of thing. And these engineers, the attorneys know one thing. The answer is no. Doesn't matter what the question is, the answer is no, all right? That's what it was. So they wouldn't let us do that. They could say we're virus-proof, right? Things like that. This system has built-in security. Now I grant you that a customer can go and remove some of the things or do some kind of foolish things. But if that security is implemented, nobody's ever hacked the system. They've never been hacked, okay? Is that important in the business world today? Is that important in cloud computing? Is that important in anything? The answer is absolutely yes, because it's designed for business, right? So, by the way, at the end of the 3 weeks, they said, oh my gosh, you built it. It will work, right? There were a few little things that they said, nah, you got to change this sort of thing, because going into the audit, my managers at the time said, now look, you got to understand, you're going to have to change something, okay? Because these people came a long way, and they're going to find something. You try to make sure you change something that's simple. And they told me a story, which is a fascinating story in IBM. The head of IBM used to be Thomas Watson, Sr., right? And he used to like to visit various locations in IBM, and one of those locations was in Endicott, New York. And I could remember in going to Endicott, New York, the development laboratory, when you walked into Endicott, the front entrance had a big glass entrance because it gets cold in Endicott, New York, right? And so you went in through this glass entrance, and then there were doors inside of that, right? And there's a story that the laboratory director, one time Tom Watson was coming for a visit that day, and the laboratory director instructed one of his people to go out and kick one of the glass panes in that entrance, break the glass. Go out and break the glass. And he did, right? And sure enough, Tom Watson Sr. came in there through the front entrance, says, there's broken glass there. And during the whole day, he was fixated on having that glass fixed, and he didn't find anything else that had to be changed. So I learned from that. So we did make a few changes. Yes, that's a great idea, we'll make that change, right? So we introduced the thing, right? 1978, we announced this System 38, rather a strange machine. I've always given IBM a lot of credit for it because it really was an experimental machine. I mean, nobody knew quite if it was going to be very popular or where it was going to go. Turned out it took off, especially with mainframe people. Mainframe people took one look at it and said, wow, that's what we've been waiting for. Because the system did so much itself, with the integrated database and all the things in there. They said, this is the kind of system we want. And we had a lot of converts of those days from that, right? But one of the things that happened in IBM, of course, in those early days, is that life expectancy of a computer system was 5 years, okay? You'd sell it for 5 years. At the end of 5 years, the sales would tail off, right? And you had to introduce a new system. That was the method in which we were all operating in IBM. And by the way, in the whole industry, it was a 5-year cycle. So sure enough, 5 years later, 1983, I get a call to come to IBM corporate headquarters in Armonk, New York, which I knew what it was about. Right? I got there, and sure enough, pat on the back, boy, did you do a great job, and we really appreciate all the hard work you put in for this System 38 and so forth. But it's 5 years, and we anticipate now the sales should be dropping off, and we're coming along with the new models and some new systems and so forth. And I joke about it a little bit, but you get a plaque, congratulations, but you also get a check, right? I ran right out and bought a 1983 Audi, the biggest Audi they made at the time, with a check. And that's all I remember what I ever did with the money. But I went home, and said to my wife, well, this is what it is, 5 years, this is what IBM says is going to happen and so forth, right? Well, an interesting thing happened. Over the next year, the sales didn't drop off at all, right? And meanwhile, IBM was planning to introduce a brand new mid-range system, which surprisingly, or not surprisingly, was a mainframe. Because they had decided that the entire world wanted mainframes. It didn't matter how big a business you were, you really wanted a mainframe, right? And so they were going to replace everything in the middle with mainframes. And I said, but it's never been designed for business, right? It just didn't, it's a good system, but it requires a lot of skills and a lot of things to run it. This will never work. So I went to work, I managed a, well, it was a group we called Advanced Technology, which was kind of a cover group for doing strange things. And so one of the things that we ended up doing, one of the projects we had, is we said, you know, this System 38 is a virtual machine. And because it's a virtual machine, it can support other environments, other operating systems, right? I mean, that's the beauty of it. You look at the latest power system today, right? And what you find is there's an underlying layer underneath all of the operating systems, right? I mean, years ago we called it microcode. A few years back, somebody renamed it a stupid name like hypervisor. You remember that funny name they talked about? Today, it's given a much nicer name, but it's the same thing. It's called Power VM, okay? Which is really it really came out of the so-called AS400 is where it came from, right? But it's that layer. And the beauty of that layer is you can put other operating systems on top of it. I mean, we've got AIX on top of it, we've got Linux on top of it, as well as IBM I, right? And I want to come back to that. So with that layer in there, I could run any operating system. Well, which operating system would I put on there? Which one do I want to put on? How about System 36, which was our other product, right? Let's run 36 applications on the 38, right? And somebody got the idea to name this, you got to give it a code name, right? And I don't remember who it was, but somebody came up with the idea to name it after an opening in the river that goes through Rochester, okay? There's a dam in the river, and there's a small lake that backed up behind it called Silver Lake. And so they named this Silver Lake, right? We put it together, got it running, showed it to executives, showed it to the rest of the corporation. Their answer to it, took one look at it and said, build it. So we did. 2 years later, we announced it as AS400. Okay? Right, well, we merged them together. Now suddenly, you know, some of us are really enthused. Because if we could put those two together, why don't we put them all together? Right? And so some of us, me included, said we should run everything on one platform. Okay? And so we set out to do that. And one of the first things we had to do is we needed to come up with some new hardware, because the AS400 needed some new hardware. We started working on some new 64-bit hardware. In the corporation, there was some work going on with so-called Power PC. Executives in the corporation, in fact, the president of the corporation, came to us, said, I want you to use this Power PC. This was a 32-bit single-user design. Had to explain to him that, sorry, but no, it doesn't work. You know, it's missing all these things. No, we're not going to use it. That's one of those career-ending opportunities when you say no to the president, right? But he understood. He was an engineer. In fact, he had worked on the System 38 in the very early days. And so he put together a team of people and let me lead it, which I thought was kind of surprising. And we designed an architecture that could be used for computer systems all the way across IBM. We call it Power. Today's latest Power uses that architecture, right? The intention of the Power architecture was to run every IBM platform and platforms we had never really thought about before, okay? In fact, late in the 90s, there was a project in IBM to sort of announce that we were doing that. The name of the project was Eclipse. It's spelled E-C-L-I-P-Z. I get by with Z here rather than Zeta. Zeta, Zeta, okay. Whenever I'm in Canada, they give me a bad time because no one says Z in Canada, right? It's, yeah, whatever, Zeta. I-P-Z. That was the platform. Run all of them, right? So what happened? 2008, we introduced Power Systems. We put 2 of them on the platform. What happened to the third one? Well, it's not there yet. Today, the mainframe processor is 95% power. It's been a marketing decision not to put it on the Power System. It will run on the Power System. Okay? Someday we hope to get that one as we start going forward, because the future of IBM, you'll see a little bit later when we start talking about some of the things IBM was doing. The future of IBM is power systems. Simple as that. That's the direction IBM is going. It's pure power systems. Nothing special, right? Early 2000, we got a call from Microsoft saying we'd like to run Windows on Power. Hey, let's put Windows on Power, right? I mean, why not? Just another operating system. I can run it on Power, no problem at all. Okay. Went out to visit them. We said, why do you want to run on Power? They said, well, we've looked at various processor technologies. We're of the belief that the power technology will be the highest performance processor technology in the industry. That's a true statement today as it was back then, right? The biggest systems in the world are built on power. It's the most powerful processor out there. And they said, we want to build some big Windows servers. Simple as that. So we want Windows running on it. We obviously want a 64-bit Windows. At the time, they obviously were 32 bits. So they said, we're in the process of actually porting our Windows 32-bit operating system to the 64-bit Intel processor, known as Itanium. And he says they're the Intel's their number one partner. I mean, it still is today, right? And they said, we have to do that port first. But once we do that, then it'll be a lot simpler moving to another platform like Power. And that's true, because in the very early days, all operating systems were pretty much built in assembler code. I mean, certainly within IBM, we built in assembler code. We also had some special operating system languages that nobody else ever used, right? And when we moved to the 64-bit RISC, as we called it, which of course was the first Power, we rewrote a lot of that. And we rewrote it in things like C++ and Java and some other languages. So all of a sudden it was much more portable if we wanted to move to a different hardware base. And so they laid out the schedule, and they said, we're going to do this port in 3 years, and we'll be on Itanium in 3 years, and then another about 18 months, and that's about right, to put it onto Power. So suddenly from the year 2000, I guess it was early 2001, we were looking at about 4 years, right? So we expected, certainly by about 2006, we actually would have Windows running on Power. This was a super deal. Now, unfortunately, my sitting in the room, I made the comment, I said, 3 years is pretty aggressive. In our experience, it's always taken us like 5 years. And there was some chuckling and laughing, and they were poking a little fun. They said, oh, but you're from IBM, and you folks take a lot longer. We're in the PC world. We move a whole lot faster. Okay. 6 years later, they completed the port. It was 6 years. They announced it. Windows running on Itanium. Fabulous product. Who runs Windows on Itanium? Anybody? No? Nobody? Great product. It really was. I mean, Itanium's a great processor. But it had one little flaw. The flaw is you had to rewrite all your software. Yeah, because Windows was never designed to run on a different hardware base. Never, right? They didn't make it future-proof, if you want to call it that, right? And the world refused to rewrite every application. Now, they don't even support it anymore. I mean, the support's been withdrawn. Typically, in a room like this, I might find one person that still has one. And when I ask them, well, why do you have it? Or what are you using it for? They say, well, for historical purposes. We're just going to keep it, right? Yeah. They put a huge, they, being Microsoft, put a huge amount of development effort into doing it. They spent a lot of money doing it. They really did. And so all of a sudden, they came back to us and said, look, we're not going to go to Power. We're going to face the same thing. We invested so much, the corporation, Microsoft's not going to spend the money to do the port to Power, so we lost it, right? So we started on a little different project, which is something that today we talk about as pure systems, right? We essentially said, look, what was the concept that was so successful for the original AS400? It was package everything together, right? Integrate everything, run all these different operating systems. And so now on something like a pure system, you can do that. The difference is it now has Intel processors really well as Power in there, right? But it's perfect for coming into an organization if, for example, you want to get started, you want to do cloud computing, whatever. It's great for that. But that's what we had to do to get that one done, right? So that was sort of too bad. One that I was really excited about, and I thought we actually got it, is running Sun Solaris on Power. Right? Why would we want to run Sun Solaris on Power? Well, if you look around the world and you look at all IBM I users in the world, most of them have some Unix in their shop, right? What Unix do they have? Answer, Solaris. Vast majority have Sun Solaris in their shops, right? You can go in there and say, well, you really should be running on AIX. You maybe want to move this over to AIX, and the answer is always no, we don't. We like Solaris. Solaris works. It's a great operating system. It really is. It's got a lot of good applications, a lot of good tools. It's really a nice one. And especially in the finance industry, almost every bank that I ever deal with, their Unix is Solaris, right? I mean, they're running their their business, their main, a core business on IBM I. And by the way, when I go visit some of these banks, I was in Southeast Asia early this year, and I go into some of these banks and I say, what's designed for transaction processing? How many transactions you're running? And they look and say, yesterday we ran 500 million transactions, and oh, by the way, we're buying some more banks, and we're going to be up to 1 billion transactions a day. Okay, I mean, it's just a huge number of transactions. They're running a power system, running IBM I, because that's what it's designed to do, right? Now, not everybody's going to run 1 billion transactions a day, but the thing can, right? Little things like that. So I was really excited when Sun called us up and said, we want to run on power. And so we went, again, to see Sun, okay? And we said, what's this about? Sun bought at the time, their Spark processors from Fujitsu. Fujitsu provides them with all of their Spark processors. And there was a great concern in Sun at the time that Fujitsu could not keep up with Intel and IBM as far as the latest technologies. I mean, when you're talking about the latest technology, you're going to spend a huge amount of money in manufacturing. The real key to semiconductor technology these days is manufacturing. It's not, innovation that you come up with. We can shrink devices down much farther than we are today. It's getting the equipment to manufacture these things, right? And so you spend billions and billions of dollars, which are good for only a few years of manufacturing. You literally throw it out. Actually, you sell it to the other part of the industry who build lower level chips, and you have to reinstall all of this. And so it's a massively expensive undertaking. IBM and Intel are really the two that do it, okay? And they were concerned about Fujitsu being able to do it, and so they said, look, what we really want is for you to supply us with the power technology, power chips. And so they were looking at Intel, they were looking at IBM, said, what's your proposal? And so we came back to them, we said, we'll supply you with the latest technologies. We laid out all the roadmaps, showed them what we're doing, everything. But in the meantime, of course, Solaris had been ported to power. And so we were able to show them Solaris running on power, the kind of performance they're getting, and so forth. It was pretty outstanding, it really was. And we said, we'll supply you with the latest chip technology if that's what you want. We'll even build your systems. We'll build your servers for you. Put Sun logos on it, whatever. We'll build the whole hardware if that's what you want. We IBM. So it was a great concept, and I was really happy about it because then, we could negotiate to be able to run Solaris on power. I mean, it was running on power, but we could run it in our systems. Right alongside of AIX, Linux, IBM I, right at the time. And so this would be great. I could go, into a lot of these customers running Solaris, say you could consolidate all these onto a power system. Lots of these companies were happy about doing that, wanted to do that. Well, it turned out that Sun decided they were going to stay with Fujitsu. And they said, well, okay, we're going to stay with them for a while longer. Okay, well, we lost that, right? So I was absolutely overjoyed one Friday afternoon when I got the phone call. I got a phone call Friday afternoon and said, keep this under your hat. We, IBM, just bought Sun. We bought Sun. Sun was going through a little bit, they were for sale, okay. IBM bought them, right? Wow, this is fantastic, right? I mean, I can think of all kinds of customers around the world that are going to be ecstatic about this because now we got Solaris. I mean, that's why, some of us wanted Sun. We didn't care about the hardware. It runs on power. We can ship Sun servers based on power. It wasn't a real issue for us, right? So Friday afternoon says, keep it under your hat, don't tell anyone. Well, I was going to tell anyone anyway. Monday morning, I go to my website, my news website, Oracle by Sun. Oracle by Sun? Wait a minute, I thought IBM bought Sun. What happened? Well, I picked up the phone and contact that I had, and I've got this sort of, second-hand, third-hand, however you want to call it, right? But apparently, the executives at Sun, the board of directors, right, wanted a big buyout. Something in the U.S. we call golden parachutes. I don't know what you'd use that term here. Yeah, they want a lot of money, right? Okay, yeah, we're going to sell it to you, but we each get our big chunk of change, right? And in fairness, I mean, I really like the fact that IBM just doesn't do that. I mean, quite honestly, IBM just never does that, right? I now know that Oracle does. So Oracle bought Sun. So we lost Sun, too, right? But I haven't given up hope. I'm still concerned that you're thinking that, there's others out there that are coming along that will put on this thing, right? I guess the point that I'm making and have been making is that we built this thing to be future-proof, right? The IBM I is built for business, intentionally so. And so when somebody says, you know, when is this thing going to go away? I tell them, well, you know, it's been going away since 1983. Because I was told by the chairman of IBM that it's going away. And you know, you got to believe the chairman of IBM. You know, they would joke with you, right? By the way, after 1983, it was the System 38. Every quarter after that set a new record for revenue and profit, until the quarter before we announced the AS400 was the highest quarter in the history of the System 38. It continued to grow, okay? And with the introduction of the AS400, it continued on up, okay? So whenever somebody says, oh, you know, this thing's getting old, you know, you're celebrating 35 years, 25 years, you know, this thing is really old and tired, you need something new and revolutionary. You know, I tell them, well, you know, let me know when it goes away, right? Because right now I'm planning for the 50th anniversary. Yeah. So what I'm going to ask is, you know, I put this maybe in the record. I'd appreciate it if you'd invite me back for the 50th birthday. Okay? With that, thank you very much. I'm going to turn it back.
You want stickers? See, that's like, we've gone from one person to four. That's a big step. Right? Would you like to pass some out?